Hello everyone, welcome to Code Grads, and today we will discuss the topic hyperparameter tuning in neural network. So we'll start with the definition, and as per the definition, it is a process of finding the best configuration for a neural network by adjusting parameters not done during training. So we adjust the parameter, neural network parameters, then in general to like the number of layers, learning rate, batch size, dropout rate to get the best values for each parameter, and through that we can solve our problems which are faced after the model building like overfitting and underfitting. Now, why can two models with the same data and architecture perform differently? If we are using two models, we have the same data, but if the parameters are different, we generally these models perform differently. Even the data set is same and the architecture is the same. So these are generally most important role they play the parameter in creating models which are more efficient to our personalized tasks. Now the types of hyperparameters in neural networks. Now the common hyperparameters shown are in case of the model structure, we have the number of layers, how many number of layers we want, how many neurons per layer we want. In case of the learning process, which optimizer we want, what could be the learning rate, what is the batch size, how many epochs are we considering. In case of avoiding the issue of overfitting, we generally go for regularization, that is a dropout and weight decay. And we also have the activation function option, which activation function will be best for our model. Now this directly affects model accuracy, convergence speed, and generalization. Now if our parameters used are best, our model accuracy increases, our convergence speed also increases, and naturally the computational cost is reduced if convergence is achieved fast. So cost complexity is also reduced. Resources are also generally used less if the parameters used are right. Now manual versus automated tuning. In case of the if we are using the manual search method, we try different values manually. If we want five number of layers in our network, then we give the value five, and it is generally time consuming, which is the main drawback. Now if we use the grid search method, it is an exhaustive search over parameter grid. Now we go for now if we give the range as 1 to 10 for the number of layers, it will go from 1 to up till 10. So it will go for each value, and it is not scalable if the data set is very big. So it is good if we use for small data set, we get the best results, but it is really bad as when we have the big data set, and in real world we generally have the big data set. So grid search is not preferred over the random search. Now in case of the random search method, it samples the values randomly. We if we consider the range for the number of layers as 1 to 10, it will first randomly pick any values like 3, 7, 8, 5, 4, and see what results we are getting. And so as it is not going up for each value, it is more efficient than grid, and it is less computationally expensive as considered to the grid search. So in case of big data sets, we generally go with random search method. Now, if we use the automated method, that is we using the Keras tuner for the neural network specifically, it uses the smart algorithms to search which we get the best hyperparameter values using the automated method, and it is fast plus intelligent search, so it is generally preferred over all the methods in case of the neural network. Now, what is Keras tuner? It is an open source library for hyperparameter optimization built on top of TensorFlow or Keras, and it automates the search process. These are some advantages. Integrate with Keras models easily, and it supports multiple search strategies. Now it is ideal for both beginners and professionals tuning deep learning models. Now in search algorithms in Keras Tuner supports random search, fixed values at random, as we have discussed earlier. Bayesian optimization learns from previous results. Generally, if you want to improve our model, we generally see how it has performed previously, and then we learn it from the previous model results and try to improve our model. Next is the hyperband. It is early top unpromising trials. Then we have the excellent tuner combines scikit-learn tool with Keras model. Now each adds strengths for different datasets and model types. Now if we use different datasets and we have different datasets, we will use this method for our personalized tasks. The key components of Keras tuner. First one is the hyper model, defines what to tune. We have the layer, activation function, etc. In tuner class runs the search using the tuner strategy. In search space, we define parameter ranges. Suppose I want number of layers to be between 5 to 10, then I will use the range as 5 to 10, and I want to see which number of layers are good for a model building. So it can be done through search space. We have the search process, try combination and find the best one. It also, when we trying to hyperparameter tune the model, we also find the best one value. Now suppose I give the range between 5 to 10 for the number of layers, it will at last give me the result that 8 number of layers is really good for our personalized model. So it is really good for getting the best value. Now it works seamlessly with functional or sequential. Keras model. This is an advantage of the components of the Keras tuner. Now, tuning process workflow. We build a model with tunable hyperparameter. We select the search algorithm. These are the steps. We define the search space. We run the tuner to find the best combination and train the final model using best parameters. We generally get the best parameter for our model, and then we input these values, best values to our model building, and then we get the model to our specific personalized use case. Now, automation saves time and improves performance. So, using this workflow, tuning process workflow, we can save time and improve our performance. Now, use case in NLP. Uh, Now, hyperparameter tuning in NLP can help optimize LFTM, GRU, model size. We can also use RNN. We can adjust the learning rate for BERT fine tuning when we are trying to fine tune BERT model like Roberta, Alberta, or basic BERT 1. We adjust the learning rate through hyperparameter tuning it. Now, tune dropout for text classification. Now, in case of text classification, we have multiple uses here. Now, generally for it generally improves performance on sentiment analysis or question answering system. So whenever the task we have the sentiment, we have to identify the sentiment of our data. Then at that task, we can use the hyperparameter tuning in NLP. Now this is a question for you guys: what might happen if your learning rate is too high or too low? Now benefits of KDA tuner: it is fast and efficient, as we have discussed earlier. Save compute by pruning bad configurations early. So whatever the computational complexity of the model is there, it can be pruned, and all the bad configurations can be avoided. It is easy to integrate with existing code. This advantage generally used in what we can say most important model building type. We need not to change the code while using the Keras tuner. Scales will well with GPUs and distributed training, which is an advantage while the cost complexity is considered. Now it is especially useful in projects where training is costly or results vary significantly. This is the main advantages why we need to use the Keras tuner. Now, challenges and consideration, we can consider the disadvantages of Keras tuner. It is a large workspace and can take a long time. So, if we give the number of ranges for a particular number parameters like number of layers, and we give the large values or large range between the numbers, then it can take a long time. So, overfitting to validation set if tuning is not regularized. Overfitting issue can be faced if the tuning is not done properly. It is resource heavy if not managed with early chopping. This early chopping parameter is most important. If we are not giving attention to the early chopping method, then it is really resource heavy. Now always monitor training time and test generalization. We need to monitor our training time, how much time it takes, and also how well our model generalizes to our text testing data. Now when to use hyperparameter tunings? When performance plateaus with default settings, when we do the manual method and we do not get the better results, and our model is not performing well, then we generally should use the hyperparameter tuning method. You need to optimize accuracy or speed. When we need to increase our accuracy or need to increase our speed, at that time we should use that. Model performance varies across data sets. So same model is not performing well across various data sets. So at that time we should use the hyperparameter tuning method and deploying a model in production. So these are the use cases of the hyperparameter tuning. Now help push performance without changing the overall architecture. The architecture remains the same, but our performance is drastically increased. Now if you see the summary of Keras tuning steps, we need to define surface using XP object. We will see further while doing the implementation part. Build hyper model with tunable layer. Use first algorithm, example hyperband, run tuner, and find the best hyperparameters. You'll also see this part in implementation and train final model with optimal settings. Whatever the best values we get after using the Keras tuner, you will get the best configuration or best parameters. It is a critical part of building high quality neural model. If you want to build a good model, and at that time, then we should use the Keras tuner. We have one more summary, and it shows the key takeaways that the hyperparameter perfect training efficiency and result. Keras tuner provides automated scalable tuning for Keras model. We have seen this earlier, and it is widely used in NLP tasks like classification, generation, and embedding. We have seen the use cases like the sentiment analysis, question answering. When we have this task, we can use this Keras tuner. Now, different strategies to different time and different constraints. These are the questions for you. You are building an LSTM for sentiment classification. What three hyperparameters would you tune first and why? So, we should discuss this question. And one more question is, what could go wrong if we overtune a model to your validation data? So these are the questions you need to discuss, and we'll see how we do the implementation. See the implementation of the Keras tuner. First of all, we'll see what are different hyperparameters in the network. So hyperparameter neural network. First is number of layers, how many number of layers we want. Second is number of neurons. Third is activation function, which activation function we want to use. Fourth is lock function. Fifth is learning rate. And sixth is optimizer. So these are different hyperparameters we should consider while tuning it in neural network. Now we'll start with the implementation part. First of all, we'll import the libraries. Import NumPy as NP, and we'll import pandas. Now we'll use the popular data set, that is the diabetic one. So we have 768 rows and 8 columns. We have different number of columns like glucose, blood pressure, skin thickness, insulin, and then we have the target variable as outcome. Now we'll see the shape first. We have dot shape. We have 768 rows and 8 columns. We'll see head. We'll see first 5 rows. Then we'll go for tail. These are the last 5 rows. Now we'll split our data. We'll try to get our independent variables in the x variable and our target in the y1. So x is equal to df dot drop column equal to, now as we know the outcome is our target variable, so we'll try to remove from it from the x variable, and y will be our target variable. Now we'll see our data looks like. We have 7 rows and target variable is not present, so all independent variables are present in this x variable, and if we see the y, we have the target variable. Now we'll do the trend test split using the scalar. So from sk learn dot model selection import trend test split, and we'll try to spread it into training and testing data for independent as well as target variable. You have x and x step. You'll have y train and y test. Now we'll the trend test split. We will give the independent variable x a target variable, and test size will give it as 0.2. So we'll see how our x trend looks. Okay, we have 614 rows and 7 columns in our x trend. Now we'll scale our data. For that we will use the standard scalar. Scalar dot pre-processing import standard scalar. We'll define it in scaling standard scalar. We'll apply the scaling techniques on our independent variables x trend and scaling dot fit transform. We have x trend, and for x test scaling dot transform. Yeah, x test. Now we'll try to import our TensorFlow and from Keras we need to import sequential and different layers. So we'll start with that. First of all, we build a simple model and then we'll see how we can hyperparameter tune this model from tensor flow dot Keras import sequential, and for layers we have from tensor flow dot Keras dot layer import. Then okay, now we'll start building our model. A simple model will build at start, then we'll go for the model. We have defined our model here. We'll add our layer, model dot add. We'll add our dense layer. We have 32 activation functions. Sorry, 32 number of neurons in the first layer. They give activation as ReLU, and then and for them we yeah, 7. We have 7 columns. So 7 independent features will be the 7 input features to our model. Now, starting with, we'll add another layer, model dot add, then one neuron activation. We'll give it a sigmoid as we have only 2 categories and target variable, so it will be sigmoid. Try to build our model. Now we'll see the summary of our model. Okay, this is our summary. We have 256 parameters and 33 parameters in the output layer. Now we will compile our model. Model dot compile will pass our optimizer as Adam. Loss will be binary cross entropy. And our metrics will be accuracy. Then we will put our model. We'll pass our X train. We'll pass Y train. Sorry, Y train. Y train. Then we will pass our batch size. Okay, batch size. Pack it at 15. And then we'll go for epoch. Pass it at 10. So it's trying to put our model now. So far we got the accuracy as 78% and loss is 47. So we'll try to improve our model using a Keras like this. So for that, first of all, we'll pip install Keras. Now we'll try to hyperparameter tune our model. We'll define a function as build model HP. Now model is equal to sequential model dot add, then give it as 122. Activation will pass it as ReLU for first layer and input then and 8. So we'll start to tune our model. So for first of all, so for I in range HP dot. Now for if you are giving specific, suppose we are considering number of layer, number of neurons. So at that time we'll give the range as integer value. So at that time we will need to specify HP dot end. Now in that specify that we want to we want to tune the number of layers. So number of layers for that minimum value will be 1. maximum value will be 10 for number of layers, and 10 for number of neurons, HP dot int number of neurons. I minimum value will be 2 and maximum value will be 128. And step size will give it as 4. Okay. Then for activation function, we'll also change the activation function. Now, as it is a what we can say, we will give different options like 10h, ReLU, sigmoid. So it will be we'll use HP dot child choice, HP dot choice for that. If it is considered for the number of layers or number of neurons, then we'll use HP dot int because we are specifying integer values. But here we are using word, so HP dot choice will be there. Activation, comma, values. Now for now, we'll give to 10h and value. Okay. Now we had the last layer, model dot add, then activation equal to sigmoid, and we know that that we have only binary categories, so we'll use the activation function as sigmoid. Then for optimizer, we'll and tuning the optimizer value, so we'll give HP dot choice and specify optimizer. We'll give values. Now we have different optimizers like we have Adam, we have Ada Delta, then we have stochastic gradient descent, SGD. So that will be enough for optimizers, and we will try to compile our model dot compile. In this part we will mention optimizer equal to optimizer. Okay. Then loss will be binary cross entropy, as binary categories are present in target variable cross entropy, and metric will be accuracy. Now we'll enter our model. Okay. Now first of all we'll import Kera tuner and KT. First of all we'll define the tuner KT dot random search, our function, build model, then objective will be our accuracy, and then we'll have directory as tuning directory. Okay, tuning will specify the project name and all parameters. Give me tune. Please tell me. Okay, we need to mention and put them inside and put them equal to 7. Okay, tuner dot search will pass our values training and testing data. Sorry, training data, white ring, and will pass epoch. Okay. Epoch equal to 5. Now we'll wait for some time. Okay. So the best accuracy so far we got is 0.79, and yeah, we total left time is 45 seconds. So we'll try to see what will be our best hyperparameter value. So for that we'll tuner dot get a hyperparameter, then dot value. So we got the list. We have different activation functions for different layers. Here summary of a model dot summary. This is the previous model. So we'll try to insert new get parameters in our model. Model is equal to tuner dot get that model, and which kind of model equal to 1. Okay. Now will be the summary. For further clear, we have 976 parameters. For second, 14,114. For third layer, we have 5,474. And for the last, we have 47 parameters. In this way, we can hyperparameter tune this neural network. Hope you understood. And please give a like to our channel and subscribe and click on the bell icon. Thank you and see you in the next video.